Okay, I'm going to show you guys how to use PyLTSpice along with just LTSpice for Python. So quickly looking this up. So you've got, this is, the Python, where you go to look at Python libraries, but you're going to need to do pip install PyLTSpice. There it goes right there. And then there's this other library, LTSpice. So pip install LTSpice. So you're gonna need both of those. You also need NumPy and some others, but matplotlib. I'm assuming that you have a baseline familiarity with Python. There's several libraries that you need though to make all this work. So anyhow, so you see here we have a circuit, right? And we could simulate this with run, and we've got a bunch of commands down here. And that's interesting. But what we can also do is, so this is PyCharm. So you'll notice here's the schematic file that we were just looking at, that .asc, and we're looking at this file here that I've written up. So you import the sim commander. That's the first thing you need. So that like holds the simulator. That'll run the simulator. We grab the path of the file. So this just tells it where it is. So we do the path and then opamp2.asc. And what this does is it creates like an LTSpice object instance inside of Python, right? So the next thing we're going to do is, so there is an add commands list or a function, but it doesn't seem to work in LTSpice or PyLTSpice. So what we're going to do is we're going to insert in the net list at the very end. So what we do is we take the length of the net list. It's just a list, right? Like a list of a string list, right? And we take the end of it, which should be a .end command, and using that, and this will generate a net list, by the way, and using that we get the last index, and then we subtract 1 from that. So we're gonna basically put this right before the .end statement, right? And so we use the insert command. This is just a built-in Python command, but we insert this little string text, right? This is our command, and then we do ltc.run and then wait for it to complete. At this point, it's going to generate a raw file, and the raw files, their naming will always be, it'll be the name of the ASC file, underscore, and then the number of runs that you've done. So the very first one will always be 1, and then down here you have 2, right? So if you do even more than this, you'll have even more. I have an example of getting the time, but we're not going to do that. So you run l.parse, right? And at this point, we're using the LTSpice library now, not the PyLTSpice library. So that's this library. And then we run get data, and we're going to get the plus terminal input. We're going to get the out terminal data. I have a print statement just so you can see it. And then here I use NumPy to take a numerical derivative of this data. What it returns is just arrays, literally just arrays of data, right? So I'm just doing some math here. I take a numerical derivative, I get the maximum of the numerical derivative, I make some text, right? Turn that into a string, I print it out. Then I make a figure with matplotlib. I plot the source. The reason that I'm doing it from 0 to the size -1 is because the derivative is like 1 longer than the source, so I have to truncate this by a bit. And then I put the text at the maximum, right where the maximum is, right? And then I plot the transfer curve as well. This is and I do a curve fit here with polyfit. This is all NumPy stuff. This isn't almost all this stuff is not related to the LTSpice stuff. Really, the LTSpice stuff is you set up the sim commander. You insert the command that you want to run, you run it, you wait for it to complete, and then you use the LTSpice library to analyze the .raw file that's generated. You parse it, you get the data from the nodes you want, and then you do whatever math you're going to do from there. And then I have another example using an AC command, because it is a little different. So we take the index that we made earlier, so this IDX up here, right? And at that location in the netlist, we're going to replace that DC command. We're just overriding this in the array with an AC command now. We run it again. We wait for completion. And again, this will generate a new .raw file. And then we parse the .raw file. And we call get frequency. And what that does is when you have an AC analysis, it grabs the frequency domain because it's not really like a variable. It's just intrinsic to the simulation. So we call get frequency. And then we get data from V out and we get data from V in. And I have a note here. So when you in LTSpice, when you plot this, you get the phase 2, and that's actually going to be in here because this will return a complex number. V out will be a complex number. And then again, I just plot it. And then let me run this, and I'll show you what it looks like. So it creates a net list for you. So you see it makes a net list, and then it modifies the net list. It's running the first simulation, and then it runs the second simulation, and then it makes all these plots. So here's my AC analysis. Here's my transfer curve from a DC analysis, and then this is a numerical derivative that gives me the gain. And the reason that these two numbers here don't match is because the gain region is actually like this tiny little spot right here. But you can see that this is pretty neat because I just ran a DC sim and an AC sim all at once, and it all plotted and it curve fit all at once. And if I change anything in here, like let's say I change this to be 8.7. All right, I hit OK, save it, go back here, I rerun this. It's going to make a new net list. It's going to override everything. It's going to simulate it again. It's going to simulate it. Boom. Okay, so this looks a little different now. See how this shifted back. This shifted back. My curve fits still work, though, actually. That's interesting that the curve fits still work. Anyhow, yeah, and that's that. That's how this works. It's pretty neat. It's very neat actually. So yeah, that's how you use it.